Hello, and welcome to part 2 of organizing categorical data. In our previous video, we used a raw data set, the one given here, to create a frequency table. And from our frequency table, we learned how to create a relative frequency table in terms of fractions, decimals, and percents. Now, we are going to look at creating a bar graph. So this is a bar graph right here. And as you can see, we have graphed the amount of coffee, the amount of espresso, the amount of soda, and the amount of tea that was sold. Sometimes bar graphs will also have labels. So for example, 16 coffee drinks were sold, 20 espresso drinks, I believe only 4 soda drinks were sold, and 10 teas were sold. So let's take a minute and think about how we could figure out the total number of beverages if we just had this bar graph. How could we do that? Well, we could quite simply add the frequencies together to find out that 50 beverages were sold. How could I then use this histogram to find out the percent of sales that came from soda? Well, I could take the number 4, because 4 sodas were sold, out of 50, and that would give me 8%. So if you have this bar graph, you have complete information about your data, and you can answer questions like this. Let's look at the rules that we have for constructing a bar graph. So notice that the height of each bar graph represents the frequency, as it does in this case, or you could also use it to graph the relative frequency for each category. The bars are the same width. Notice that that is true. This width here is the same as this bar and this bar and this bar as well. The bars should not overlap. That is true. There's a nice little space here between each of our bars. Moreover, each piece of data should only belong to one category. And again, that is true. Coffee has its own bar, as well as espresso, soda, and tea. So make sure you follow these rules when you create your own bar graphs. Let's move on to pie charts. Again, we're using the exact same data. We have coffee, espresso, tea, and soda. So how do pie charts work? Well, they show how the size of the category relates to the whole group. They're really good for showing percentages. So as you can see here, espresso accounts for the largest amount of sales. And so this wedge of our circle for espresso is 40%. In fact, it's almost half. Then, second to that is the wedge that represents coffee, this blue wedge right here. That's 32% of our sales. Then we can see that the yellow part is smaller, and that represents 20% of our sales that came from tea. And then 8% is the wedge that came from our soda sales. If you were to construct this manually, which obviously we usually use technology, but if you did, you would have to use the fact that there are 360 degrees in a circle, and then you would construct a proportion. So for example, if 40 over 100, or 0.40, is the amount of sales we have from espresso, you would just set that equal to x over 360, and then you could cross multiply and solve and find out the measure of the angle here that you would need, and then you would have to use a protractor. But as far as you're concerned, in our courses, we will always use technology. If you have Microsoft Excel, that offers that feature, and if you're taking my stats course, we use StatCrunch to generate pie charts. Okay. So what are our rules when constructing a pie chart? We need to make sure we always include relative frequency or percentage. So that's right here. Here's my percents. And we need to include labels. That's super important. In real life, you can see that this is different colors. However, when I print stuff for you guys, a lot of times it comes out in grayscale, and so it's hard to differentiate between each of these wedges if the shades come out very similar in grayscale. So notice that in addition to having this legend over here, I also have the labels superimposed on each of the wedges. So keep in mind when you do these sorts of things, it's good to use color in your legends, but also think about, are you printing it, or what if someone's colorblind? What if someone can't see those colors? So you want to make sure that your pie chart is very clear. All right, let's do a few examples. So here we have a very, very simple pie chart, and ironically, it's representing literally the amount of pizza that was consumed. So looking at this, what % of the pizza did Bob eat? Now, some people would say, well, there are 1, 2, 3 different wedges, and Bob is one of those wedges. So Bob ate 1/3 or 33% of the pizza. But is that true? Is that what the pie chart is really telling us? Well, no, it's not. Look at how much of the pie Bob ate. He ate literally half of this circle. So he didn't eat 1/3, he ate 50%. And again, we know that because of the relative size of Bob's wedge. Okay, what % of the pizza did Iris eat? So again, you could argue that there are 3 wedges, and she ate one of those wedges, so it's 1/3. But let's look at the shape of this. So this is exactly 1/4 or 25% of the whole pie. And likewise, Tammy also ate 1/4 or 25% of the pizza. Make sure as you're doing this, everything always adds up to 1 or to 100%. And in this case, it does. Let's do one more example. All right, take a minute and you can look at this pie chart. So this is telling us the state of origin of a bunch of people. So we see that Maryland is the top. Then we have other. Then we have Virginia, Pennsylvania, and West Virginia. Let's go back to our rules from pie charts. What is this pie chart missing? Remember, it's supposed to give you percentages or relative frequencies here, and it doesn't do that either on the legend or on the pie chart itself. So technically, this is really not a proper pie chart. However, I wanted to give you guys this exercise so that you could practice identifying and understanding visually what pie charts are telling you. So what is the most common response? Well, to answer that question, we really need to look at what is the biggest wedge of the pie. To me, it looks like Maryland is the biggest wedge. So I would say that Maryland is the most common response because it has the largest wedge. What was the least common response? Well, to me, it looks like it's West Virginia. And again, I'm going to say that simply because it is the smallest wedge. And then lastly, which responses were closest in size to each other? So this is a little bit hard to tell visually. To me, it looks like this light blue wedge for other and the dark blue wedge of Maryland. Those to me look like they're the most similar. So I would say that it is other and Maryland.